and 3 people flew in to speak at a conference on innovations in data engineering. They had flown in from Amsterdam, San Francisco, and Cape Town to speak at QCon at the Queen Elizabeth II Conference Center with a view onto Westminster Abbey. One of the 3 speakers, Hannes Muehleisen, was a professor of data engineering and creator of an analytical database called DuckDB. Another, Frank Yu, was a director of engineering at Coinbase, specializing in high-frequency trading at microsecond response times. And the third was a staff engineer who had created a transactions database called TigerBeetle, and whose only database distinction was that he lived next to Table Mountain. Different degrees, different databases, and yet that rainy evening in London of that rainy day, the 3 HFT, OLAP, and OLTP hailed a black London cab to drive down Black Prince Road and to walk like hobbits into the Black Prince pub. Such was the conversation they had that Frank, Hannes, it's a real pleasure to catch up with you again today.
It's really a pleasure to be here. Thanks for the invitation. You remember much more about that evening than I do, honestly.
I just remember sitting
Your
there.
Your reread of that.
Yeah, I was just
warms
listening.
my heart.
Yeah, Frank. Yeah.
No, thank you very much for the invite, and just your retelling takes me back to that time.
Yeah, it was so good.
Wonderful.
And the Gamble was there too. I'm sure he's listening in. He was talking about online build processing systems. So, but I just remember listening and thinking, seeing in my head, wow, we should do this live and everybody can join in. I just remember listening. So,
although I have to censor myself and only say half of the things I've said. You know, it's also like I have to sort of restrain myself a lot from all the shade that's been thrown. It would have been enough for an entire beach in Florida, but
yeah, you don't have to restrain yourself. We almost had the London Calling soundtrack, and we're fine. We're in London in a pub. There's nobody else but the 3 of us. We're not even live. This is just a recording, so we can edit. Just tell me when you want to edit, and we'll
that's that. Excellent. Yeah, I might. Sometimes I need a second take, so I will just say.
Yeah.
I mean, it'll be our challenge to pull the shade out of Hannes. It's gonna be great.
That's a great challenge, actually. Maybe, yeah.
Yeah.
For me, it was also really exciting because I never talk to people that do anything with like transactions or consensus. This is just completely foreign to me. Like, what? We don't do that. It's it's like, what do you even care? But you'd explained. It was very nice.
Yeah, that's what I thought so interesting, is how we've got so much in common, and then there's so much more advanced stuff in OLAP and HFT. And so I feel like if we're 3 little brothers, I'm the smallest and the youngest, the toddler, and OLTP is, and HFT, OLAP, who's the biggest. That'll be interesting, like to sort of compare and contrast and see what's similar, what's different. So yeah, so right off the bat, basically I'll go first. I'll kick off a question and then over to the 2 of you, and we'll pass it around and see where we go. So Frank, high availability. So OLAP and OLTP have a big O for online. Mission critical, must be online all the time. But I noticed there's no O in HFT. It's just high frequency trading. But you don't have to be online. This is the funny thing, I thought, So even though you have a consensus protocol, in the past, you can actually just go to sleep at the end of the day when the market's closed. You just shut the system down, shut the exchange down at the end of the day. And then you've got the luxury, you can do all your background work, catch up at midnight. And then in the morning, you wake up, you go to work, and you switch on again. So HFT didn't have to be online all the time, or maybe you tell me. But I think it's changing, chatting to you behind the scenes. You need to be more available these days. So yeah, what's the architecture to make this happen?
Yeah, I mean, let's bury the lead a little bit. Let's talk mostly about kind of where we started, right? Like my background, traditional markets. Me, I'm not a trader. I run exchanges. So what that means is traders around the world are connecting to our systems and submitting orders to buy and sell, submitting orders to open positions, close positions, tell everybody what the price of any given thing is. And yeah, as an exchange, we give you really good uptime and really great response times. I mean, so much so that it's not strictly online. We're not connected to the internet in the traditional world. We're connected in very specific places with very specific network lines coming into our machines. And, folks move their computers right next to ours because these response times are so important that the speed of light is a huge determining factor in, what you actually get. Like if I send you an API call, packets, they're limited by the speed of light into our system. So from there, I think we give you great response times, but only during business hours. When you can tell when you go deal with your bank or you try to sell some equities or you try to invest in something, the markets close and you kind of just hang, your order, if you place it over the weekend when you're off work and you actually have time to go do investing, it kind of just sits somewhere, right? And it only gets in at, I think, 9 a.m. East Coast, some specific date, right? But I am now in the crypto space, and crypto doesn't sleep. Markets are constantly flowing 24/7, and now we didn't need consensus before when we were not 24/7, but now we do. So I think the big one is the introduction of consensus into this space, but also making sure that consensus actually performs sort of at the highest levels. Right? This is, I think, a big change that has occurred in the last, say, half decade or so.
Can I ask you a question, though? A stupid question,
yes.
I know. But like the market used to be open like 8 hours or whatever, how long Wall Street decides to work, right? Like, I mean, these people close their bank at 5:30. I don't want to guess how long they actually work, but didn't you need, like, if it went down in the middle of the market day, it would also be a catastrophe. Like, what is different from that? Like, why do you need consensus now? Why didn't you need it before? Like, could have crashes as well or something.
So the big one here is that more, I think, resiliency, right, does not necessarily need consensus realistically, because these machines are running so fast. You can handle basically the entire, and they're so highly optimized. You're handling basically the entire world's throughput on basically a box in a given market. And so realistically, you kind of have sort of a primary and a secondary. And, when that primary goes down, which is maybe once every X number of years, you fail over to that secondary, right? And the big thing here is that when it's time to make upgrades, to change the software floating on it, you can bring everything down and you don't have to worry about sort of leadership election and all that. You don't need rolling updates. So that's, I think, the big key there. Once you get into 24/7 space where you're now changing the tracks on the train while the train is driving, you're going to need to make sure you have some set of rolling updates. You can't simply go in, shut everything down, switch all the hard drives out, all the network cards out. So I think that's basically the big driver of why you've gone to a consensus space that basically just considers updates as sort of a normal course of action, right?
Right, that makes a ton of sense. The update one, that's like what the Erlang people also have implemented, because they implemented the thing for like Swedish network, like telephone switches or whatever, and they had to able to essentially during a call do a software update, like without dropping any calls. Is that a bit like how this feels to you, or?
Absolutely, and I think maybe a unique situation here is that these the financial infrastructure underpinning everybody's accounts and retirement funds and this and that. You need a little bit of auditability and determinism. You can't sort of play games with failover. You kind of want to make sure that what happened actually happened, because when things get reordered around, people literally lose funds or gains funds out of it. You can't be in the business of picking winners.
That's super exciting. I mean, sorry, Joran.
Yeah, no, no, the professor shouldn't say sorry.
Don't keep telling people this. They will think I'm old.
Okay. It was really funny because we were in that track at QCon in London, and the track was innovations in data engineering. And then I realized, like, of all the speakers, Hannes, you are a professor in data engineering. So
That's
was really
right.
cool. Yeah, that's why you went last in the track at the end of the day. I went first, I think.
Well,
Anyway.
you still did a way bigger, better speech than I did. So, like, it doesn't
No,
really matter what titles you have. Like,
I'm still-
if I learn some, I'm sorry,
yeah, no, you mustn't say sorry.
talked over you. That happens a lot.
Yeah, the latency. But I'm still, like, whenever you do a talk, I'm sitting there with a camera. I'm trying to capture a photo of that slide of yours with the hamburger. And I'm trying to catch a photo of that slide of yours with that duck on picking your cheek, because that isn't on the internet anyway. So
It is. If you go to the DuckDB FAQ, there is a hidden link in the FAQ to the picture with the duck.
I've been looking all over, like Google doesn't have it.
Yeah.
Now I know. Yeah. But yeah, Frank, I wanted to ask you also, like, what's the architecture to make high frequency trading happen? Like, what's the most common?
So traditionally, right, the most important thing is that you need sort of the hardware and the networking infrastructure, right, to make this stuff work. You know, we talk about sort of speed of light mattering. You want folks who are fundamentally have their servers in a co-located or near each other physically, right? And in some sense, this has gone out to the web world with sort of edge computing and all of that stuff, right? Like it makes sense if my packets are going over the ocean across the world. Min response times are in the hundreds of milliseconds, right? And if our expectation is we need to respond in less than a millisecond, right? And maybe in the fancy stuff, even less so than that. It's really important that the hardware is there. So I think the combination of sort of that 24/7 space and this low latency space has really been made possible in kind of the last basically few years. This is all kind of bleeding edge stuff. You can get fairly great co-location of your physical stuff in the cloud now. And a lot of this is commoditized. You can basically write up something, infrastructure as code, deploy it to the major cloud providers, and actually be fairly close to the people you want to talk to. So this, I think, has unlocked, and none of this is anything we did, right? This is all something that just, the society of compute providers and networking providers have given us. And that has enabled us to now take basically things that have improved reliability in the web world, right? So consensus algorithms like, say, Raft and other things, and now we can deploy them onto the cloud, co-locate them, and get some nice software optimizations to actually get under that millisecond inside basically all on commodity hardware. And that is, I think, a huge game changer, especially for the crypto space, which is now significantly more democratic. Everybody does not need to go rent a space in a very specific data center in New York or Aurora, right? You now get on, look up the documentation for the exchange you want to trade on, and go deploy your endpoints right there next to the exchange, and anyone can participate now. So what that means is, I think that's the big change in the architecture, is that it's now possible in the cloud, and I can stick Raft inside the cloud. And Raft, there are implementations that are basically properly latency sensitive now, that are open source. And we certainly have built a lot of stuff on some of those technologies. So hopefully that makes sense there.
Yeah. I actually glad you mentioned the millisecond response times. I wanted to double check, is it like microsecond level per transaction on average, but like could you tolerate that like 1,000 transactions take 1 millisecond, but then on average you're getting 1 mic per transaction, or I take it like that's not possible.
I think we are talking about microseconds here, right? So we're trying to stay sub millisecond in our P99.9s, right? And what that means is minimizing jitter, basically controlling all the variables that might cause delays when you're processing a request in your system, right? So that means any bit of code that your request is touching, dealing with pathological cases, any bit of networking that your packets are going through, dealing with those cases, and also dealing with things like OS scheduling and all of that. So, like I said, it is now possible with a little bit of craft to actually control most of the variables that matter and keep your 99.9s under, and maybe only take delays when you actually do full upgrades and failovers, right? Which are, if you do them when you change your stuff, that's not every message. It's maybe every trillion, who knows, right? So you can still maintain that 5 nines uptime while providing great service for your customers, right? Sweet. So I am gonna get some heat off my back. I'm gonna throw something over.
So many questions.
I know, right? I'm gonna throw something over to Hannes, right? So DuckDB, right, is an analytical database, which makes sense. But we're talking OLAP here. What makes it an online database? What does that even mean? And we already talked hamburgers. So
yeah, hamburgers.
What makes what makes DuckDB online?
Online. Well, it's on the internet. And we have a website, but no, this is like I think this comes back. Huh?
It's on the line.
It's on the line. That would be the high frequency trading people. I think they are sitting on some line and getting excited there. We are not doing that. But I think actually I recently looked this up, so I want to say one totally weird thing first, because I was so excited when I found out. Did you know that the first table that we know is 5,000 years old? It's from Uruk in today's Iraq, and it was 1,000 years before we had the first text written down. So basically, tables precede literature. This is such a mind-blowing thing that I've been thinking about this, and then I went, okay, so what happened then? And then a bunch of stuff happened, and I also didn't know this, but we owe data management systems, digital data management systems running on digital computers. We owe that to the space program of the US space program, the Apollo program of all things, because the Apollo program had such a mind-blowing complexity in parts that IBM got a contract to do parts management for the space program, and they built a first database management system called IMS, running on the IBM 360. Now, if you cast your mind to the IBM 360, it's this room full of things with people well-dressed, very different from today, right? People are well-dressed, have like suits and whatever, and they deal with the big machine on the IBM 360. And that was all batch, right? So you would give it a job, and it would run at night, and it would compute whatever it was. So the online, as far as I'm aware, and I might be very wrong, and some graybeard may jump out of the woodwork every second now and tell me that is wrong. But as far as I'm aware, online meant, when it first came around, that the analyst was actually sitting there interactively typing queries, and then push a button, and then it would happen right there and then. It would be online. It would be not batch. I think that's how I see it. And it's actually quite interesting how this is so super different from like streaming architectures that are also very much not batch, but in a different way not batch, right? Like it used to be batch meant like you come back in the morning and get your query results, and then online meant, okay, now we can actually do an aggregation. So like the most basic OLAP operation there is like an aggregate on a couple of thousands or even millions or billions of rows, sort of while waiting for it. I mean, I know that the open source space of OLAP engine is actually quite terrible, honestly. Like, of course, ourselves excluded, but there is actually not. There's like a lot of this technology is kind of hidden in sort of some commercial product that nobody's ever heard of. And the open source options are actually not great. But I think from my understanding, and I may not be an expert on this, it meant just that you have a live sort of view on your data. Now, the client-server protocol, which kind of is this fundamental assumption that drives this online aspect, where it means like you're not dumping like a bunch of punch cards in like a bucket and you get your result back on a printout. Now you're actually connecting live to the database server. I actually did some digging on that, and that was also like because I have nothing else to do, obviously. It turns out that was invented in '84, so it's not like it's not that old. It's actually something that is so ingrained in our thinking now that we have this client-server protocol that talk to a database server, to OLAP, that we stop thinking about it. But these are not necessarily. This is not a necessary precondition. Like for OLAP engines, I think this whole network distributed consensus thing is actually not a requirement, right? Like some people have tried to build these scale out things and they talk to each other over network, sure. Some people have built like the 2-tier architecture to talk to the thing on network, sure. But it's not really a requirement. Like we don't necessarily have to talk to other computers to do this stuff. It's also very often you have data on a computer and you want to analyze it, and that's it, right? Like I think for the trading, it's very much reactive in nature, right? You get some information in, you have to react. It means you need to talk to other people, and then they obsess about the length of their cable. Is it, by the way, true that the cable lengths are like standardized and everybody has the same cable length or something like that? I read this somewhere.
There exist exchanges that will try to standardize the length of the cable, because I think in general, folks that basically high volume traders are kind of most afraid of getting an advantage over them is Pierce. Right? And so so the exchange, we're in the middle, right? Our job is to provide great service, provides let's say great service and also fairness, right? That's fundamentally what an exchange does. And all the participants who are, let's say, the sharks are mostly worried about cannibalism. They're mostly worried about the people next door. And so there have been exchanges that have said, okay, for fairness, we'll literally tell you how many cables, how many, what distance of cables that will actually connect. And if you happen to be closer to us, like physically, we'll coil your cables to make sure that all those distances are aligned. So that is absolutely true.
That's. I also have a second story that I want to check with you, because I also heard this, and I thought it was interesting. They said like, yeah, there's like in Chicago, there's a lot of like trading, high frequency trading people, and then there's like 3 data centers in New York they talk to, and they're like 50 kilometers apart. But it ended up making 3 cables all the way from every single one of these data centers to Chicago, separate, 5,000 kilometer, I don't know, 2,000 kilometer cables, because that was more interesting than just merging all the cables and going there, because you could have a shorter response time. Do you know if that's true?
I definitely heard that story. I don't know if I can confirm or deny, but cables are one thing, right? But there's also lots of innovations happening in the non-cable space in that world too. So again, a lot of cannot confirm and deny going on there. Again, so that is with the mature market, right? You can kind of expect that in a very competitive mature market, you can expect that a lot of that stuff gets squeezed out, right? And innovation gets driven because a lot of folks competing with each other are trying to get that edge, and that edge just quickly gets to the rest of the community, right? Now, I would say, I think a lot of that stuff creates a pretty big barrier to entry for participants who want to participate in these traditional markets and who might be interested in this space. And so I actually do think the competitive landscape inside the crypto space is a little more significantly more democratic and will allow a little bit of disintermediation of some of these some of these tricks and hacks that people do to try to get an edge off of folks. Because at some point, when you kind of remove some of the tools that people have to minimize, to get that edge, people maybe can start focusing on maybe less pathological strategies. But yeah, there's a lot of fun stuff that happens in the traditional markets world.
But I really like that you give me like a ball to sort of play immediately, because democratization is actually also something that we care deeply about. Because as I mentioned, like lots of this tech is in OLAP engines is like buried in other technology. So there's like this interactive data analysis tool that I'm not gonna name because I can't throw shade, but they bought a super innovative data management system, also not going to name, the smartest people in OLAP. But now it's like, because it was bought by Salesforce through hops, whatever, it's now doing one thing, which is driving Tableau, which is super sad, because it means that this technology, which is really great, isn't available to the world. And I think if it had been available, we may have never started this. Brings me to the hamburger. We really strongly believe in that bringing like the online, which doesn't have anything to do with cables, online as an interactive data analysis, state of the art for the people, is like really our mission, if you think about it, right? And the hamburger that we showed, and I know Joran likes to make fun of our hamburger, and it's actually not my metaphor. I stole it from Jordan, who is the CEO from Mother Duck. He says, look.
Just to say quick, Hannes, when I first saw that slide, I was getting my phone out, but I was so slow. I tried to take a photo, but you'd moved on, and I'd lost it. So I thought it's like that is the best explanation of what you're about to explain. But I love that.
But
slide,
the crazy thing is, we didn't even realize ourselves that was what we were doing. We were like, we make it like. Sometimes it takes other people to kind of tell you what you're doing, and that was really funny, because we were building this engine. We thought, like, we make one for the people and blah blah blah, bring the state of the art or something close approaching it to many people out there, and that means it has to be unobtrusive and has to be easy to use. It can't be client server, because that's not a great user experience for OLAP, because you cannot ship big amounts of data back and forth. Fine. But then they were like, no, you're just looking at the end-to-end user experience, like the hamburger, right? Like, if you have a hamburger that's, you can't have a good hamburger without a good bun, that's pretty impossible. And whether it's vegetarian or not. And so that is kind of, that really is sort of what drives us, is to try to give this technology, which essentially has been around for a long time. OLAP stuff has been around forever. Like, people had a small detour through like Hadoop and stuff, and now they're all coming back to data warehousing systems, which is OLAP stuff. Okay, sure. Maybe they have gotten a little bit less weird because we don't talk about cubes all the time anymore. Sure. But still, it's about like closing this huge gap that existed between like the state of the art in research and the state of the actual world. Like, there's tons of people out there that do like analytics with Postgres, and there's nothing like fundamentally wrong with it. It probably works up until like 15 rows of data or something like that, right? But and that was just such an expression of despair, if you want, because there was simply nothing else out there that people could use, right? So that's kind of what we're trying to do there. But this is really, for me it's super interesting. And you mentioned this earlier, like we were these three little like guys sitting in different corners of the database space. But for me, it is really, really, really exciting, because I don't know anything about high frequency trading, as I have evidenced 5 minutes ago. And we are so different that we cannot possibly be competing with each other, which is really exciting, because then you can actually talk to each other and not be concerned that the guy is gonna, steal your great idea about whatever. But we haven't really heard anything from you yet, Joran. So
like you said the other day, Hannes, isn't it nice that we're not trying to eat each other's hamburger, not trying to eat each other's
Did I say
lunch.
that? Oh my God.
You didn't say hamburger, you said lunch, but I changed it too. Yeah.
Okay. So, but I mean, that's exactly right. Like, I think you, and there's so much to be learned from each other, but we haven't heard from you yet, Joran, and you are the one that has set this whole thing up, but you're different online. I think you're like OLTP and OLTP means another online yet again, and I honestly don't remember what it was.
Oh, so OLTP. So I don't know. Is TigerBeetle really OLTP? So I
don't know.
I didn't used to think so, because we just thought, well, we were looking at a payment switch and it was using an OLTP database like Postgres or MySQL. I thought, now that's OLTP. And then the switch was building something around it that we looked at, and we thought, well, this is also a database in user space, in application. People are constructing hamburgers because there's the patty, but there's no experience that you need for tracking financial transactions. So you could do raw database transactions. But it was maybe even last year, we were still thinking like TigerBeetle is an accounting database, because we just thought, well, that's the best way to model financial transactions, is again like that ancient table, like double entry accounting is pretty ancient and good way to represent business, all around the world. No matter the language you speak, there's accountants, and they speak double entry accounting, debits, credits, and that's how they model any kind of business, any industry. And so we looked at this payment switch, and it had an OLTP database like MySQL, Postgres, and then around it there was this other database. So we didn't know what to call it. But anyway, that we said, well, let's give people a real hamburger that they can now track financial transactions. But I was actually like you, Hannes. I was also like diving into history of things, and it really surprised me, because we thought like we came at this from just first principles, looking at a real problem and how do we solve it. And then we were digging in, and we used to say, well, we're a specialized database. And then it started with Andy Pavlo, like we spoke on the CMU series, and he introduced us saying, it's a transactions database. And I thought, like, are we, I thought, oh, okay, that's nice. We're kind of OLTP, it feels good. And then like recently, looking at the history, there was this paper which introduced one of the first popular OLTP benchmarks, and then I fell off my chair because the benchmark was called debit credit, like literally, and the exact workload was TigerBeetle. Like it's exactly what we built for the switch. Financial transactions, and then like the name, I think, database transaction is how you implement that physically, but the logical thing is a financial transaction. And then I fell off my chair again, because that paper was anonymous, but I actually found out it was Jim Gray, and he had like 24 co-authors, but he was a tandem at the time. And Jim Gray obviously gave us the 5-minute rule and coined ACID. And then that debit credit got so heated with benchmark wars that the Transactions Processing Performance Council, I think, is that right? You will know better. They were formed to standardize, and then you had TPC A, B, I think C and E, but they were again all in a financial context, like banking, warehouse inventory, and a brokerage firm. So then I felt encouraged, because I thought, oh, this is OLTP, is online transactions processing, where transactions are business transactions, any kind of business transaction, debit, credit. So,
but I think it's really funny, because that this match is there, because it's also when we explain databases to like undergrads, we'll always add specifically transactions, right? It's always like, okay, Alice wants to move $5 to Bob. What can happen? Like, it's the standard textbook example. It's so painful that I try to avoid it, because I don't want to gar the students with like all this banking terminology, because they don't really care that I have like an app for that. But I think it's also maybe one of these lies of abstraction sometimes, right? Like, we build data management systems and we make them hyper abstract. So it's a table and it has things in it and whatever it is. And then we'll build systems with the maximum abstraction level, where it's like, we don't know what the table is going to be like. And you have taken sort of the opposite approach. We're like, no, it's always the same table. Stop lying to yourselves. It's true.
Yeah.
And you can be better, because you realize that you can't stop lying to yourself, and you don't have to solve a general problem. You have to solve the double entry accounting problem, which also I didn't really know about before we talked about that. So I think it's really fascinating, because it's like a counterculture trend or something like that. Like, it's like, no. screw the abstraction. This is what we're gonna use these things for. And if you look at, I don't know how many relational database systems are there, transactional ones are used for that sort of thing, right? Like it's pretty ridiculous, I think. Like they're probably like 50%. I don't know.
Yes.
I don't know.
No, I love that you bring up the canonical textbook example of this is why we have a database is Alice pays Bob's money must move once. Because we realize, okay, I've taken time to learn these things, but what I learned last year, November, is that as we were spinning our TigerBeetle was that, yes, this is the example everybody gives, but when you look at the abstractions, there is no abstraction to do like how do you do debits and credits? That isn't the interface. So then people build a database, and you can go so much faster, if you like. This is what we found, this impedance mismatch. So if you're trying to do a financial transaction, it would typically across many systems turn out to be 10 SQL queries. So you're doing one thing and getting 10 network requests. And so then you're trying to increase your scale by 1,000 times. And now you get 10,000 network requests a second. And now you want to do 1 million transactions a second and you get 10 million network. So it just doesn't work, but we realized it's the double entry workload and it's standardized. It is another standard that is very old, and because I said
have
to
you
you,
won TPCC yet? Sorry.
So like I said, we're taking a while to learn these things, but we're realizing, okay, wow, let's next year let's look at TPC. Like, how do we do? So that'll be interesting because. Yeah, one of the things that we learned also is with tracking any kind of business transaction, there's always a debit and there's always a credit. So money is moving from one person to another or something. You're going from one place to another. It's like a vector, in the physics sense. Not in the AI sense, apologies. So I didn't mean to trend on us now, but so it's just it's an edge, between two nodes, and some quantity or value is moving from one person or place to another. But what we realized is that the debit side could be high cardinality. You could have 1 million customers, so you can shard that easily. You can scale that horizontally. But this is the challenge. The money is always going to the bank account on the credit side. So that's low cardinality. So that's one row. So you could have 1 million customers and you happily inserting on those rows and taking row locks. That's fine, no contention. But you got tons of contention on the hot bank account, which serializes all your shard performance. And that's why this workload is so challenging. But yet it's a lot of people have this problem, and usually it takes a while, once you really, anyway, that's the story, OLTP. So.
But I also want to mention something that the benchmarks get in the way of the hamburger, honestly. We've seen this time and again that people that go for the benchmark first, they will literally compromise everything in terms of sort of end user experience or even developer experience to win that benchmark, right? It's no, databases in analytics, the famous example is no overflow checks. They're slow. We don't do them. Bam. Now you can be better at a benchmark, although you get some wrong results, but people typically don't check the results of the queries, shockingly. But you have just compromised the basic principle of it. So I feel it's very dangerous. So I think you're doing well by not doing that just yet.
Thanks, Hannes. I'll remember that word of warning. And I love Jim Gray. He had a paper and he said correct and fast, not one or the other, but both, and always correct first. And I'm not going to mention the name because they're going to be actually angry at me, but I've heard there is a database system out there that doesn't get correct results on their own benchmark and refuses to talk about it. Okay. Or maybe you can drop it in the chat.
So the problem that you raise, right? The sort of lots of customers, one hot bank account, right? That big synchronization point that you can't get away from that basically wrecks all your sharding, right? Um, that problem is quite similar to an exchange. Basically, the reason why sort of the stuff has gotten kind of so focused on basically single-threaded performance is again similarly, if I want to buy an apple for $1 or something like that, I want to have my buy order checked against everybody's sell orders for apples, right? And if someone's willing to sell an apple for 99 cents, but then someone else is willing to sell it for $1, I should get the 99 cents, right? And so that fundamental thing again is this sort of is sort of a hub and spoke where you have lots of folks kind of trying to agree on something, right? And fundamentally that has to do with accounting. Now, I'll say, we are maybe less of a technology provider. We're maybe more of an infrastructure stability and service provider. So, for us, a lot of financial institutions process transactions, right, including us, and generally in the middle of it is some database. And the first thing that lots of exchanges will do is, well, you can't process, million transactions per second hot on your traditional databases, and we pull it off, right? But it sounds like the problem that you all are solving is very similar to an exchange. So is there a world where you see some of the highest throughput systems actually rely on some of the rigor you all are bringing to the game for basically ledgering?
Yeah, so I agree with you, Frank. Like we actually were looking at like Martin Thompson and LMAX, and we were just looking at that architecture of an LMAX exchange, and like that's what we did for TigerBeetle. Like, and the idea was we designed the consensus and storage engine that you can take in one database query. You can take like 8,000 of these standardized debit credits, send it all through in one request of the network, f-sync it, run it through the state machine logic, and reply. And that way you execute those serially, but there's no locks anymore. So the CPU is like a 100-meter sprinter. It just goes, and you don't have to like do network communication across the coil, across the cable, the CPU just runs. So yeah, it's all thanks to the work that you folk are doing in HFT, like this. So that's why I thought, yeah, and I think in OLAP also this idea of like how fast is a single core. I'm pretty excited. Like Hannes, I think this is why we like to come and hang out in Amsterdam, is because we want to learn from what you're doing, because we look.
This is why you're coming to Amsterdam, right?
Yeah,
yeah, that's it. I mean, actually, come to think of it, we also have a collision domain. When we run like an aggregation of 1 billion rows, and then there's like few groups. Like if you do aggregation and you have like 10 groups, you get a lot. Like everything has to go. You have to fold all the state, everything in those 10 groups, right? So it's very different, but it's also like a collision domain of where it's like, yeah, that needs to be fast. But yeah, single node performance, I think single core performance for you guys, I think single core is more important than single node. For us, single node is important because we need that firepower. For us, the metric is like cycles per value or something like that, and then we need all the cores because we just have so many values to get through. And then it has like other problems in like how do you then reconcile all these things happening in parallel, and there's like wonderful architectural questions around that. But I feel like it's a very different world because it's always about volume. It's always about, there's always like an insane amount of cache pressure. And we have this, I think it's called the Parkinson's principle. I looked this up some years ago. It's like the work has the tendency to fill the space available for it. Like if you make it 10%, you make it 50% faster, people just make the data set bigger. It's very annoying, right? I feel like with like real world transactions, yes, there are some sort of societal changes or that maybe increase the number of transactions. I remember you Joran talking about like how microtransactions really just blow up these traditional financial systems, and I believe that. But I always say, anything that's like limited by human activity is probably manageable on a single node. But still, like for us, it's just like people just stuff more and more data into it. If you increase the capability, they have like no qualms of just adding more stuff to it. So it's always like a bit of a losing game, which is why we have to be extremely, like we have to basically keep pushing this. And sometimes you think, no, clearly we cannot push this anymore. But then some clever person comes around and goes like, haha, we'll do this. And then, for example, recently we learned that like if you do early abandonment of aggregation hash tables and just throw them away and rebuild them, that sounds super wasteful. But because it lowers the cache pressure up in the stack, it's actually faster end to end. You go like, huh? So there was a paper on that coming, but it's one of these things where you have to find solutions where you like least suspect them. Do you also have this, like where you think like, okay, so now we need to actually do something different in a place where nobody else is doing things differently, right?
Yeah. Frank, do
you have that?
I would say that, one goofy thing that we ultimately did with an exchange we did recently is on the cloud, commoditized hardware, right? But, cloud providers will charge you for network egress and ingress, right? So for us, we kind of realized that, okay, when you receive just any message or whatnot, to do everything sort of remote procedure call, right? RPC, like I receive a thing, I send you an acknowledgement in the same channel. It's incredibly slow and blocking. Right? So in general, exchanges have been doing this sort of event streaming systems just for many, many years, right? But one thing we kind of felt about sort of this sort of event sourcing paradigm is that you would take a request, like let's say some person who really loves apples is down to buy 1,000 apples or trillion apples at at any price, right? So what's going to happen is that one request coming into our system is going to spawn like 10,000, 20,000 transactions, right? A single response may call, and in the database world, this is simple. If I go accidentally and type drop, I think drop a table will just like, on Postgres will just like create a massive explosion of wall entries, right? So there's sort of this kind of weirdness with, things coming in and things coming out. So I think in the financial world, because we are fundamentally running a ledger, we're just keeping track of things that happened. It's really nice if our systems are deterministic. Right? So what we've gone ahead and done is, our logic is pretty fast because we optimize that, and it's kind of fundamental to everything, and it's pretty correct because if it blows up, that's it, right? So we put all our engineering effort into sort of the central processing, our logic, making it fast and safe, just like you say, correctness first, then speed, right? So we thought, hey, let's not disseminate the effect of what is happening. Let's just replicate request logs, right? So we find ourselves actually basically rerunning our hot logic in multiple parts of our system because replicating the inbound log is generally a lot smaller than the outbound log. If I took all of the queries I make on a transactional database and just like even just keep them as strings and just put them in a nice little text file, like run these in serial, like that's probably way less data than the explosion of write ahead log entries that come out, right? So we've definitely done some things where we're flipping the thing upside down and we're thinking, whoa, like, are we nuts? I don't know. Like, folks generally don't do this, and if we have a bug, that means our bug replicates too. So it better be correct, right?
I love that technique of yours. Yeah. We did something similar. Sorry, Frank, over to you.
No, I was saying that like I wonder about how you all have actually been trying to solve this problem as well.
Yeah, we do the same. Just like Hannes was saying, like these tricks that you just turn things upside down and you put on the lateral thinking hat and think oblique, and by the way, I said like Joey is on the TigerBeetle team, and he does all the drawing. So we had like the duck on Hannes' shoulder, Frank as Yoda, like wizard with the glasses, and then I said to Joey, "I fly with my hands," So he sort of captured us, I think. And but we came up with this trick yesterday where we realized we have a LSM tree in-memory component. Every time you update an account, we update the indexes and we spray them into the LSM forest, into all the in-memory tables. For each index is its own tree. So you update one account and we spray indexes, and you do that 8,000 times per database request. And then we realized, hang on, like of these 8,000 row updates, again, it's like 10 of them are the same account. So we're spraying index maintenance like over and over again. Like, let's just wait. Like, let's wait till we get to the end, and then we know, okay, these are the unique objects. And now, but you see, both of you have done this many years before us, so we realized this yesterday. Just to defer, you can amortize your index maintenance, because again, like we clearly separate the operations, the requests. So you have read-only operation, and then a write operation or read-write. So we know that we don't have to maintain indexes if we're not going to use them for 8,000 updates. And
Sorry, that was me. It's the bedtime for the kids.
Okay. Do you want to pop out, Hannes? You good?
No, I'm not here. I'm at the office. It's just they're on their own, but it's just my default alarm. Sorry about that.
No. Yeah. But so I want to play my change of direction card. Hannes, back to you. One of the things, moving on to correctness, one of the things like really impressed me in London, from your talk. And by the way, your talks were like amazing. Frank and Hannes, like both of them, they were just incredible. And one of the things that really impressed me with DuckDB, so I spoke about durability and how in OLTP databases, there's work from UW-Madison that, we had fsync gate and data loss in OLTP, and we're still solving it. We need direct IO to come in until it's properly solved. And protocol-aware recovery, showing how consensus protocols are broken unless they have, implement this 2018 paper, which is a problem because many of the systems were designed and built before 2018. And which is something that really shocked me, or just struck me as we were doing TigerBeetle 2020, because we realized, wow, there's so much storage research. There's actually it's, there's so much we can do. But what really impressed me in London was that chatting with you, Hannes, then you're like, we get this right. We're OLAP, and if we see a problem in the write-ahead log, we tell the user. We don't try to fix it, which is what OLTP would do, and then get into trouble. But like DuckDB, you really care actually about durability, about transactions. You call fsync.
We do, yes. Yeah. Although we have recently run into problems, I have a fun story that you haven't heard yet. So we try really hard, and it's my personal favorite is somebody running DuckDB on a Samba share, on WSL Windows subsystem for Linux or whatever Linux system Windows. I don't remember. And it's yes, there is a fsync call. It purports to do what it was supposed to do, but of course you both know that this is totally wild, right? And but this is this is known, remote drives are just the devils, and you have no way of detecting this as a system, right? No way. This just looks like a file system, and now we have the stupid cloud, right? And now people abstract file systems on 3 levels because, okay, it looks like a file system, but actually it isn't a file system. It's some S3 map thing that happens somewhere in some Amazon code that you have never seen or will never see. And we have ran into this interesting problem because in DuckDB we had this assumption that we write the file format is blocks, and it's blah blah blah. We have blocks, they're checksummed because we don't want to trust that the disk gives us the same bits back. Great. And then we have the blocks are fairly big. They're 256K or something like that because we're doing OLAP. Blocks have to be fairly big.
By the way, we were in the office today. We were chatting about block sizes, And like OLTP, we've got these teeny tiny block sizes. And we were saying, yeah, things are moving towards bigger block sizes. And we were like shocked, you know, and then we said, yeah, DuckDB are at 256K already, and
we don't have to make a single update. I mean, it's not what we do, right? But the problem was that our assumption was like, yeah, okay, it's like even if the disk is like breaking, we will maybe get a couple of page writes through, and then it will break, and then we'll see next time in the checksum read that the block has not been written correctly. However, all these helpful layers underneath then start batching requests together, and we just go like, all right, let's write this entire block, right with the checksum and everything, and then the layer below us has actually batched this together to one request to the background storage system. That failed, which meant the entire block was in the old state. And you go, I haven't thought of this problem before, right? Like that you could possibly lose an entire block, right? And you would not be able to tell because the checksum is still correct. It's the old one. You're not seeing it. Like the fsync went through. Like it's every layer is lying to you, right? And then I thought, oh, this is a whole entirely new class of storage like screw ups that I haven't even considered yet, and probably Joran you have. But I mean, it was one of these things where it's extremely difficult to get right. Yeah, I can see you getting excited about storage.
Yeah, no,
do you know this one? I mean, that one was like what?
Yeah, no, just the concept of a lost write, but I didn't know the inception problem where you're like 3 layers deep in durability dream. That's a first.
Right, so. And somebody actually makes your failure model was like, this is going to fail somewhere halfway through and we'll know, to this is one request now, and it goes through or not. We have no way to know. Like it's... But we actually are quite conservative with like how we talk to storage because we have to run like on friggin' watches or something like that, right? But I know that you guys are like doing like our heroes of the async IO kind of stuff. Like that's are you getting like a lot of like? Is that something that's really critical to what you do, or is it more like you just enjoy it so much because it's a fun API?
The IOU ring. Yeah. So we did tests, and I think a lot of people. You get like mixed benchmarks on the networking side, because often you get very simplistic benchmarks. So I think the trick is you have to think of IOU ring as a system benchmark, like that you can amortize system calls, and we did test it in that way, and then you could get like double the write throughput if you were doing 4KB like write ahead log appends, which we do. In one case, but also it gives you a very nice API because you get to do networking and file system async, like no kludges. It's just perfect. So, and I think if anybody knows about like what the right interface is, like Jens Axpo's done such amazing work, and the design, mechanical sympathy. So like, Frank, you will know like ring buffers. So I kind of grew up on Martin Thompson's work, and then I saw IOU ring buffers. I'm like, yes, this is it, you know. Yeah.
Dream come true.
Ring buffers will eventually, take over everything. Now, that said, those have been around forever, and it's sort of, I think you have the people who really know that stuff being like, oh, well, finally, y'all are catching up.
Yep.
But is it also, I mean, for you guys, Frank, is it also the same sort of problem that, I mean, you're not necessarily storing things to disk, right? This is unique to like Joran and mine's like suffering of this world that we have to persist some things to disk. You don't necessarily have to do that in Exchange, or like not at the same sort of like hot path kind of problems, or am I looking at this completely wrong?
So in traditional markets, the answer is basically to help have the hardware that will really help. So in one of our solutions, we actually have, I guess the business line's been discontinued. I don't know how we'll get anymore, but Optane drives. So basically 3D X-point, more or less powered memory, right? And in that case, life is super simple. You control your own hardware. Yeah, I'll fsync my write ahead log, my RAF log, and life is good. I can actually get in, get out within basically a few mics and have fantastic durable low latency response times. right? But I think cloud, it's a different world, right? You don't control the underlying stuff as you mentioned. And, generally the solution for kind of having some amount of durability is in 10 places and you're checksumming them all against each other. And maybe what you're doing is you're also, gating your consensus protocol on having multi-availability zone, multi-region. But in our space, right, going ahead and taking my data, replicating it from, the East Coast to the West Coast before I respond to a client, that's basically an outage every message. So I think in our world, right, it's about user education, about what disaster recovery means in this space. And in some sense, when an exchange goes down, it indeed is a disaster. So I think we can convince clients to say, all right, what is your failover strategy? What is our failover strategy? And then for the vast majority of cases, things are fine. And when a hurricane hits or tsunami hits, then you execute your business continuity protocols, right? So a lot of this stuff, I think, we're basically outsourcing the kind of long tail events out to people. Like, people have to solve these big problems, but for the 99.999, we want good service, right? So cloud, I guess the other thing I should mention, an annoyance about just sort of cloud hardware, is you store stuff to disk, and you store stuff to fast disks, but in a lot of providers, you lose your instance, your compute instance. You don't get the disk back. And it's reasonable, right? Because you might have noisy neighbors. They may not be able to get it back to you. I mean, that's perfectly reasonable. But if my disk might just get lost, not because of a power loss, but because of, I don't know, a software glitch or something like that, then why bother that space? So
no, I remember in London, Frank, how you were saying you like to strongman an argument and try and make it as strong as possible, to understand it. And I remember chatting about F-Sync with you. I wanted to say, we found another one of these way out things. And we, normally in a consensus protocol, in Raft, in the paper, it says, when it's safely replicated, when you have a quorum, then you execute through the state machine, and then you reply to the client. And we realized that actually maybe that's overspecified, because Frank, you could append to the log and replicate in parallel, and in parallel start executing through doing your CPU work, so you can pipeline CPU IO. And then you just have to wait to externalize the reply. But you can actually do speculative state machine execution and then kind of approach the performance of in memory, but you're doing full F-Sync and even replication if you tune your buffers, so that CPU.
That sort of an algorithm, I think, takes... this is actually sort of used in a lot of traditional markets. Basically, the sequencer architecture, where you just have one thing over here sequencing your requests, and you have other systems that are reading that log and doing whatever business logic they like. But what that generally means is this whole deciding who's going to respond to what becomes another leader election issue. Right? So you've now sort of multiplied your kind of leader election problems n times, and I think this is definitely done in different places, right? Because you can decouple the maintenance of your log, your actual sequenced log, with your business logic. But
so just to clarify,
that kind of adds perturbations everywhere.
Oh yeah, we'd never do that. To clarify, we were thinking that you still wait for the quorum to externalize to the client. So it's only if the primary fails or is partitioned, if you do a view change, then you just discard your execution result buffer, but you don't externalize to the client. So it's just that you get a head start on execution, and if your speculation is confirmed, you just reply. But we're gonna see next year. Then I'll let you know if it works. I thought you would like this because it sort of, we don't have to worry about the cost of fsync or consensus anymore. Now we can beam, but this is why I asked you earlier, like, would it be okay if you could have 1,000 transactions in 1 millisecond? So you're getting 1 mic on average, but I think for you, for HFT, it wouldn't be okay. Like, you want 1 mic.
You want, in general, to provide good service, you basically want individual requests to kind of have to all be consistently good, right? That said, in the networking space, of course, like, routers and stuff are doing implicit batching because that just makes sense, right? But in general, batch operations for people who are maybe latency sensitive, you should be fairly upfront with them back to the client by exposing basically batch APIs. And so being very straight up, hey, here you go. This is going to amortize your thing. You get to make the decision. Right?
Absolutely.
But in general, we try to avoid variable length requests.
Yeah.
Because we're kind of scared of unbounded computation inside a transaction, right?
Yeah, absolutely. Like, we got it from Martin Thompson, just make batching first class, let the client decide policy. And But I don't know, what do you guys think? Is it time for, we've got about 5 minutes left. You think is it time for bold but somewhat questionable statements? Thanks, Hannes, for suggesting this game.
Yeah, it's the best.
Okay.
Thankfully, it's we can later edit the recording, and then nobody will ever know what kind of embarrassing things we've said. So.
Fair enough. I mean, I think I should go first as a consumer of technologies, right, and a provider of services, but mostly a consumer of technologies. You both are running open source businesses. Like, is that going to work?
I don't know. I've never studied business. I mean, it's. It works for us because we don't have investors. We bootstrapped the business. We did get offers from VCs. We had to turn them all down because in the end we thought we want to make technology that everyone can use. That's not going to disappear in silos, and that we can do best if we don't have to have like 1,000x return of somebody's investment, which allows us to basically give this thing away under the MIT license and not worry too much about our future. That's a different situation for many companies. I mean, I think it's a really, really tricky decision, and for us, if we're still happy with it, but I can totally see how people struggle with it.
Yeah. Thanks, Frank. I love that you asked the question. And I'm with Hannes on open source, and we were lucky because both our investors, like Coil, like the spin out had to be open source because it came from an open source Apache 2 switch, and the copyright was owned by the Bill and Melinda Gates Foundation. So it's not changing. I'm not going to say to Uncle Bill, like, oh, Bill, we're relicensing. He's going to say, like, well, I don't know him anyway, so I can't, who am I? But it's very nice, so we're like full on open source. And our other investor, Amplify Partners, that's what's impressed me is they said, well, we're in the Adam Jacobs School of Open Source, make the tent bigger. It was like, no, not a thing, But actually, it makes business sense also because I think if you're a salesperson, you love to actually give people a good solution. It's very difficult to go up to a business and say you should build your mission critical transactions around this thing. And by the way, it's a monopoly. You'll never have any other company that can service you. So I don't,
Isn't that how Oracle works?
Yeah, and it's so, well, I don't know I'm not allowed to say anything. But I think things are changing, so you want to build trust and say to people, well, we're actually building an ecosystem that there are businesses that can service you, and you should choose the best, the one that, who are you going to trust? This is mission critical, who understands, because it's really complex, like what DuckDB do, what you do, Frank, HFT, or like what we do, TigerBeetle. Like we know this thing, it's kind of like chess, we want to fix a distributed systems bug, and there's a chess move, and you think this is the right fix. And then you think through the second order effects and you realize, oh, that's going to lead to split brain and data loss. And then there's a second move and you think, okay, but it's the third order effect, and it's kind of like, this is what people want, is trust, who do they call to really understand these things. But I think the same is true for open source, is that actually that's the best chess move, because it's the beginner business rookies, if I can say that. They think, oh, let me just be greedy. I'm going to be a monopoly, and obviously that's great to sell, but it isn't. Our people we chat to, they say, yeah, like open source, we don't consider anything else. So it hurts your adoption. But on top of that, I think like if you look at BSL, it's a terrible defense. It doesn't give you the defense it promises, because this is what I love, like Kafka is like, 10 years old. It's fantastic, but it's also 10 years old. So Red Panda came along and said, well, we see your open source. We don't want it. We'll rewrite it anyway, because this is how software works, so the BSL doesn't protect you. You can't, it's like playing on the sand, building sandcastles and walls and moats. A wave of innovation is just going to come. Just play in the water, paddle out, catch the wave, and be ahead. You just be one of the great surfers and be out front. There's enough for everybody. And I think DuckDB are showing that. So, and again, it took me a while to figure this out, so it's like second order thinking. That's what we like to say. And we're just grateful that the whole company, that everybody, the investors, this is what we're committed to, so. And hopefully more engineers, we will just understand positively that, hang on, just because it says business doesn't mean it's good for business, because nobody ever explains why. It's just assumed that you can slap on a BSL and you'll have no competitors. But people always compete on the interface. They're not going to disappear. Now you've just lost your opportunity to define the interface. Now you're going to be worrying about people who are going to do that. So rather just, get the cavalry into the field, just be out there, don't hide behind the castle walls. Anyway, enough analogy, but I love open source. Yeah. Oh, so yeah, it's just, and I think it comes back to like HFT, OLAP, OLTP. What we want to do is make a technical contribution, and I think like some of these things, I wouldn't want to work on it if it wasn't open source. No one on the team would, because it's more valuable, if it just feels better, if you can give people a great consensus protocol and it's open source. That was my.
As long as it's not Apache, I think that's not a hot take that I think. I think that one of the big misunderstandings is that people conflate open source and open governance and think it's one of the same. And I think we've seen where open governance gets you, namely into the very weird world where the project just grows out of control and out of, like also usability, because it's everybody is getting their feature in. And I think you can have a very happy open source project that doesn't use open governance. And it's like, why is this not used more? I think people just like, no, it's open source, so therefore we must be making everyone happy. No, hell no. Like we don't have to make everyone happy. We want to make a large amount of people happy. But like if some weirdo comes out and says, I want this thing, this patch, and like sometimes we just like have to say, no, it's not happening. Sorry. And I think this is also one of the secrets that you can use to keep your sanity alive. I mean, I know other companies, I'm not going to name names, but companies that are like built around an Apache project and they're struggling so much. Actually, Databricks is a good example. They're big enough, they're not going to care. There's a great example where they're just struggling also with the governance of a huge open source project where like their competitors are paying people to contribute to this project and therefore getting a say in the governance, and they are, as Databricks themselves, the people who actually wrote the damn thing and invest the most money, and are actually struggling to keep a handle on it. Like, why?
Yeah.
Anyways.
Yeah, you
Rant
need
over.
to have a good chef in the kitchen if you want the hamburger to taste great. And you need a team. You need a team of chefs, but there needs to be like a taste. Or what do you say, Hannes? For Frank, is there a BDFL?
I think it's definitely a good idea. I mean, we're here like 100 meters away from the office where Guido von Rossum built Python. So it's I think it can work. Yeah.
Yeah.
But who is it, right? Who's going to be this person?
It's got to be someone with a duck on their shoulder,
No, it's not. We are two people. That helps. We have to talk to each other before we piss someone off. That helps.
Yeah.
I think the big one here is, and this is a common story, a parable I like to tell, is that there's a reason Unix was called Unix, right? And Unix basically ran laps around a committee project called Multics. And it is very difficult to overestimate what just a single thread, a single person, a single just strong conviction can get done, and some amount of free time and no distractions, right? So.
Yeah, well, I just want to say, I'm so glad we could catch up, and I'll never forget hanging out with both of you and the gamble at the Black Prince in London. And such an honor to, you're both, like I say, big brothers, or, for us at TigerBeetle, all of the team, we really love the work you do. So thanks for joining us.